Alright, good morning functions. We are going to continue with doing this kind of math. We learned how to do numbers or bases to higher powers yesterday by using long multiplication. So I'm going to start by doing this one. So we actually know what 4 cubed is, right? So 4 to the third. Whoops. Let's go back. 4 to the third is equal to 64. So I need to multiply that number by 2 more 4s. So we have to be really careful. So I know that's 4 to the third. So I need to do 4 times 4. So 4 times 4 is 16. Bring down the 6, carry the 1. 4 times 6 is 24. 24 plus 1 is 25. So 256 is 4 cubed, but I need to multiply that by 1 more 4. So that's 4 to the 4th. So then we have 4 times 6. 4 times 6 is 24. Carry the 2. 4 times 5 is 20 plus 2 is 22. And then 4 times 2 is 8 plus... Alright, so 4 to the 5th is equal to... I don't know why I keep saying that. 1,024. So I want you to do the next 2 on your own. And then when we look at this one, what we're going to ask ourselves is, since we're looking for a square root, something times something is going to equal 14. So what times itself equals 14? And then this is the same thing. Something times something times something is going to equal 1,000. And what is that something? So that's what those 2 questions are asking. So go ahead and do that. Hit pause and get that completed. Okay, so without using a calculator, I got 729 for 3 to the 6th, which makes sense because when we did factoring by cubes, we had one that said 729, and we took the square root, and we got 3 to the 3rd, right, 27, and then that was a perfect cube, so that makes sense to me. So 3 to the 3rd times 3 to the 3rd would equal 729, and then 2 times 2 is 8. I'm sorry, 2 times 2 is 4 times 2 is 8. So 2 cubed is 8 times 2 is 16. So 2 to the 4th is 16. 16 times 2 is 32. And 32 times 2 is 64. So 2 to the 6th is 64. And then 20 times 20 equals 400. I know that 400 is a perfect square, and I know that it's 20. I also know that 1,000 is a perfect cube because it was up on my wall, so I knew 10 times 10 times 10. All right, that is what we are starting with. So yesterday I gave these notes in class, but I want to make sure we do look at them one more time because I want to go back to this one. We knew finding the square root was 20 times 20, so then the square root of 400, the square root of 400 has to be 20 because 20 times 20 is 400, and the cubed root of 1,000 is equal to 10 because 10 times 10 times 10, 10 to the 3rd power equals 1,000. So we're going to keep using that idea. So we know that the square root of 36 is 6 because 6 to the 2nd power, 6 times 6, is 36. So yesterday when I said being able to do this long multiplication is going to help us, it's because we have to figure out what's going to multiply over and over and over again to get to that. Because if we take any root, it could be any root of a, and that is equal to b, then that means that this to this power is going to equal what's underneath the radical. So go ahead and hit pause and get this in your notes if you didn't already. We're going to kind of break up and dissect and explain what exactly a radical is, or a root, or whatever. Okay, so the number a in this example, this number a is called the radicand. The number underneath the radical is the radicand. I typically refer to it as the number under the radical, but the actual word is radicand. The n is the index, or the order. That tells us how many times we need a number to multiply to get to this number. So our index right there. And then the expression, the whole thing, the entire thing is a radical, And then this little root sign right here is called a radical sign. So typically we'll say this is the nth root of A, or n radical A. So that's two different ways to say the same thing, but that is what we're going to be dealing with for this part of the unit. So go ahead and get this in your notes, because I am going to expect you to know what an index is. I'm going to expect you to know how to say the nth root, or 7th root, or 10th root, or whatever it is that we're doing. If you have any questions, please let me know. All right, we're moving on. Let's see. So taking those ideas, we have to think about what is going to multiply 3 different times by itself to equal 27. So we know for sure it's not 1. We know for sure it's not 2, because the number underneath the radical, right here, the radicand, isn't even. We know that. So it can't be 2, because 2 to any power is going to be an even number. So then we'll start with 3, because if we start with 3, we might get to it first, and then we'll move on from there. So 3 to the first power is 3. 3 to the second power, 9. 3 to the third power, 27. So then it has to be 3, because 3 to the third power is 27. So let's try 216. So just thinking logically, we don't need to start back at 2, because we already know that 3 to the third power is smaller than 216, so we can start with 4. So 4 to the first power, 4 to the first power. So I'm holding up one finger, and the reason I'm holding up one finger is so I know I'm at what power. So 4 to the first power is 4. 4 times 4 is 16. 16 times 4 is 64. So then we're done. 4 is not it. 5 doesn't work because it doesn't end in a 5, but 6, let's try 6. So 6 to the first is 6. 6 squared is 36. 36 times 6 is 216. So then it has to be 6. All right? So now I want you to try for the 4th root of 256. So we already know it's not 6, because 6 is right here. 6 to the third power is right here. And if we multiply this by 1 more 6, we're going to get a number way bigger than this. So I want you to go ahead and try this one on your own and see what you get. So hit pause and do that. Okay, so you should have gotten 4. 2 is going to be too small, and then the next even number that you would pick is 4. A trick that I was saying that you can figure out for 3s, if you add all these numbers up, so 2 plus 5 is 7, 7 plus 6 is 13. If that's a multiple of 3, then it's divisible by 3, and that means that you can figure out if it's 3 will be able to get to it. It just will take a really long time. So that doesn't work. 3 doesn't work. So 4 would have been the first one I started with. So then you end up with 4 to the 4th power. So 4. So now we're going to take the 5th root of 243. So probably not 2. I'll let you go. Hit pause and try this one. Okay, so you should have gotten 3, because 3 to the 5th power is 243. All right, 2 more. Okay, so now we have a fraction, right? And when we first started this unit, I usually rewrite them as the 4th root of 16 and the 4th root of 81. So, oops, wrong pen, I was going to grab them. Let's see, where is it? So I usually would rewrite that as the 4th root of 16 over the 4th root of 81. So then I would deal with each one of those by themselves. So something... It's a pretty small number, so I'm going to start with 2. So 2 to the first power is 2. 2 squared is 4. 2 to the third power is 8. 2 to the fourth, oh, that's got to be 2. And then 81, still a fairly small number. It needs to be multiplied by itself 4 times. So I'm going to just jump to 3. So 3 to the first power is 3. 3 to the second power is 9. 3 to the third power is 27. 27 times 3 is 81. So this is 3. So that's how I would do that one. So you should get 2 over 3 because 2 to the 4th power over 2. Another way to write this right here would be 2 to the 4th power over 3 to the 4th power is equal to 16 over 81. So that's how that works. All right, then the last one, I want you to kind of think about this one because we know some things, so I want you to try that one. So hit pause and try this one. Okay, so we can kind of think of this as a multiplication trick. So what times itself is going to get me to 0.064? Well, I already know that 4 to the 3rd power is 64, right? We did that before. So if 4 to the 3rd power is 64, I wonder how I can use that information. So we can do this with decimals. Why isn't this? There we go. So it's going to be 0.4. Because remember, when you multiply 0.4 times 0.4 times 0.4, we know that we're going to get 4 times 4 times 4 is 64. But when we have 3 decimals, so 0, 0, oops, and 0, there's 0. Okay, we have 1, 1, 1. We have to take the decimal and we have to move it over 1, 2, and 3. So we end up with 0.064. So that's just a quick reminder from like 5th grade math when we multiply decimals. I know many of us haven't done it in a while by hand, but we are going to be doing that. So just remember, kind of look at the number and then think about how many decimal places. So you may need to mess with it a few times. Maybe if it was 0.006, it would be 0.00064. Then you would be able to do that. All right, if you have any questions, please let me know. And then the last thing we're going to cover today is the nth root. So, about the nth root, we have some special rules. If n, meaning my index, this is the index, if my n is even and my a is positive, then that represents the principle of the nth root of a, meaning it's possible. It is possible. So this has to be even. So 2, 4, 6, 8. This has to be positive on the inside. Then it works. If we have a negative on the outside, then that represents a negative of the n. So of the nth root, sorry. So like let's say, I'm going to give you an example. So for this one, we'll do the square root of 64. Okay, the square root of 64 is 8. All right, that works because this is even and this was positive. Now, if we have negative, and I'm not going to write the 2, 64, negative square root of 4, this says this is negative 1 times whatever the square root of 64, which is 8, which would be equal to negative 8. Okay? So if the n is even, and this sign is negative, so if this is a negative a, then this is not a real number. So you kind of think of it this way. Can you take a square root? And in the universe of all real numbers, can you take the square root of negative 4? No. This does not equal a real number. So it would be an imaginary. This would be 2i, which now is not a real number. Imaginary numbers are not on the same plane. Remember, they're above. All right. Now, if the n is odd, if my index is odd, so when it says n, it means index. If my index is odd, then there is exactly one nth root of a written. So if this is odd, then I'm going to have exactly one real number, meaning this could be positive or negative. It doesn't matter. All right, we are going to end with that. We're going to do a couple of examples here. So we're going to find the root. So I would like you to hit pause and do that, and this is how we finish class today. So here are all the answers. Make sure that you caught that the negative was underneath the radical sign here, so it is not a real number. If you have any questions, let me know. Otherwise, hit pause, and I will make sure you check, or I'll talk to you all later.